Hey guys, so today we're going to be working on 4.2 angles of triangles out of Unit 3. Okay, so first thing we want to look at the triangle angle sum theorem. Okay, it talks about the sum of the measures of the angles of a triangle is 180 degrees. What that means, we have angle A, so the measure of angle A plus the measure of angle B plus the measure of angle C equals 180 degrees. Okay, so it doesn't really matter what these angle measurements are, but as long as all three of them together add up to be 180, then we are in fact having a triangle, and it proves that triangles angle sum theorem. Wow, that's a mouthful. Okay, so as far as an example goes, right, we are given a soccer field. Okay, the diagram shows the path of a ball in a passing drill created by 4 friends. So 1, 2, 3, 4 friends. Find the measure of each numbered angle. So with this, we have angle 1, 2, and 3 that we need to solve for. All right, we could start with number 1, but it could be a little challenging. All right, I like to think of this as a puzzle piece. So start where you have the most information given that gives you the easiest one to solve for. So when I look at this top triangle, I'm given 2 angles already. So I'm only missing the 1. So I want to start with angle 3. So knowing my triangle sum theorem, the measure of angle 3 plus the other 2 angle measurements has to equal 180 degrees. Okay, so 3, 20, and 78 all have to add up to be 180 degrees. Okay, so when we add these together, we're going to get measure of angle 3 plus 98. Right? So the measure of angle 3 is going to be 82. Okay? So that one's done. Right? Next angle I want to look at, we still can't really get over to number 1 yet, so I'm just going to go to number 2. So think about this angle relationship we have here. Remember when we talked about angle relationships, whenever we have 2 lines that make an X, the angles that lie across from each other are known as vertical angles. So, what do we know about vertical angles? All right? Vertical angles, remember, are going to be congruent. So, since we know that vertical angles are congruent, the measure of angle 2 has to be 78. Okay? Our last angle that we're looking for is number 1. Okay, so I just determined that angle 2 is 78 degrees. All right, and then we need this missing one right here. So just like we did for angle 3, we have 2 measurements already. So we have 61 and the 78 we just solved for. So knowing our triangle sum theorem, this measure of angle 1 plus these 2 measurements here has to be 180. So the measure of angle 1 plus 78 plus 61 equals 180. Okay, so adding these all together, we get a total of 139. All right, and then taking that away from 180 leaves us with our measurement of angle 1, which is going to be 41. Okay, so moving on. All right, so we just talked about the interior angles, but now we're going to talk about the exterior angles. So this is still the same topic, but now we're going to be looking at the exterior angle theorem. So this theorem states that the measure of an exterior angle of a triangle is equal to the sum of the measures of the 2 remote interior angles. Okay, these are going to be the angles that are opposite and far away, but still within your triangle. So, for example, the measure of angle A, like we have here, measure A plus measure B equals the measure of angle 1. So when we add A and B together, we get this total angle right here. So for example, if we have A being 30 degrees and B was 105, we would know that 130 plus 105 equals a total of 135, which would be our missing angle number 1. Looking at an example of this, we have an individual doing triangle pose. Okay, she's making a triangle with her legs in the floor. We need to find the measure of JKL. Okay, JKL is this angle right here. We know that JKL is equal to 2x minus 15. All right, 2x minus 15. And then we also know, because of the exterior angle theorem, this angle and this angle have to add together to give us this angle. Okay, so substituting that in, we know JKL is equal to, remember, this angle and this angle, these two remote interior. So x plus 50. Okay, we know that JKL is equal to 2x minus 15. Okay, so now we're just going to solve for x, because in order to find out this missing angle right here, we have to solve for x first. So doing that, we're going to get x on the same side. Okay, we have x minus 15 equals 50. All right, and then adding 15, we get x equals 65. So remember, 65 is just the value of x, not our angle. Okay, so we know JKL equals 2x minus 15. We also know that x equals 65. So after substituting that in, we're left with 130 minus 15, leaving us to know that JKL equals a total of 115. All right, so looking at this in another way, look at this interior angle. Okay, we know x is 65. We also know and remember, our exterior angle equals these two interiors added together. So 65 plus 50 is in fact 115. So there's technically two ways you could solve for this, okay, after you figure out what x is. Right? Looking at our corollaries. Okay, corollaries are extra information that are important to know. So this one states, 4.1, acute angles of a right triangle are complementary. So we have a right triangle here. These two angles here, A and B, are acute, and they have to be complementary or add to 90 degrees. Okay? So acute angles of a right triangle are complementary. All right? 4.2 corollary states that there can be at most one right or obtuse angle in a triangle. Okay, that's important. Only one in a triangle. Okay, because remember, a right triangle is 90 degrees. Obtuse is larger than 90. Okay. For example, if L right here is right or obtuse, J and K have to be acute. And remember, acute is less than 90. Okay. And then last example, we're going to find the angle measurements in right triangles. So we have this shape here, some sort of parallelogram. Okay. We have 1, 2, 3 triangles inscribed. Okay, then we need to figure out what the missing angles are. So we have 1, 2, 3, 4. All right, I'm going to start with angle 1 because I have a measurement of 52 here and a 90-degree angle. So I know that whatever's remaining will help me add to 180. Okay, so the measure of angle 1 plus the interior angles inside, right here, 52 and 90, gives me a total of 180. So the measure of angle 1 plus 142 equals 180. Okay. Once we subtract that 142, we are left with a total of 38. Okay, now that we know angle 1 is 38 degrees, I'm just going to go in order and go to number 2. Okay, can I solve for 2 yet? Well, I have a right angle here and 38 here. So I have two angles already and just missing angle 2. So let me change colors real quick. And then we're going to add 2 to the angles that we already have. 38 and 90, remember, is a right angle. These all have to add to 180. Right, so angle 2 plus 128 equals, again, 180. Leaving us with an angle measurement of 52. Okay, so angle 2 is 52 degrees. All right. Knowing what we can tell about angle W, so this whole corner right here, it's marked as a right angle, all right, and we know that when two angles are adjacent, they add together. Okay, so these two adjacent angles sitting next to each other have to add together to give us 90. So we have to solve for angle 3. So the measure of angle 3 plus 52 has to equal 90. Okay, because this is what we're looking for. Subtracting the 52 from both sides gives us a total of 38. I'm noticing a bit of a trend here, aren't I? 38, 38, 52. Let's figure out what 4 is going to be. Okay, so last one, we have a right angle here in this corner because this line is perpendicular. So when you have a perpendicular line, it makes two right angles. Okay, so this is 90. We just determined that angle 3 is 38 degrees. So let's find our missing angle 4. What do you guys think it's going to be? I think it's going to be complementary to angle 1. But angle 4 plus angle 3, which was 38, plus 90 equals 180. Right? And there are other ways that you guys can add these together. If you're subtracting them in your head or anything like that, that's fine, as long as you understand the reasoning behind it. Okay, so the measure of angle 4 gives us 52 degrees. Okay, so remember 52 and 38 together is 90, so this is actually a right angle as well. Looks like we have a true parallelogram. So, you guys have any questions, let me know. Make sure you work on your assignment. Thanks for being here today. Bye.